is phase wave propagation. Phase wave propagation. So what is mean by phase wave propagation means this phase wave propagation. You can transmit the electromagnetic waves for the space two types. Okay, first one is here directly you can transmit the space. So directly you can transmit the electromagnetic wave transmitter to receiver. That is the first process. Second process, you can transmit the space. Okay, you can transmit the electromagnetic waves from the space. That signal goes to the earth, reflected to the space for the space receiver. Okay, that is a two-way propagation, two-way communication. That is a direct communication and indirect communication. That means indirect means that signal goes to the earth, reflected to the space. Okay, there is a two types of communication available for the phase wave propagation. First one is a direct wave communication. Second one is a indirect wave communication. That is a indirect wave communication means that signal goes to the earth, reflected to the space. Okay, that is an operation of phase wave propagation. Right. So phase wave propagation. Okay, so phase wave propagation, you can communicate the two types of communication. That is a direct wave and indirect wave. So direct wave means you can transmit the electromagnetic wave from the phase transmitter to receiver. Suppose you can send the earth means that is a second wave communication. So electromagnetic waves goes to the earth, reflected to the space. So these electromagnetic waves are high frequency waves. The electromagnetic waves are high frequency waves. Okay, so that is the first point. The radio waves having a high frequency are basically called a space wave. Okay, this radio wave is a high frequency, basically called a space wave. These waves have the ability to propagate through atmosphere from transmitter antenna to receiver antenna. Okay, so what is the second point is? The second point is that you can transmit the electromagnetic waves from the direct and indirect for the transmitter side and the receiver side. Okay, so this electromagnetic wave, that is this phase wave, can travel directly or can travel after reflecting from the earth surface to the troposphere surface of the earth. Okay, so there is a two-way communication. There is an indirect wave and a direct wave. So direct wave means you can transmit the electromagnetic waves to the receiver, transmitter to receiver. Again, you can transmit the reflecting process. So you can transmit the electromagnetic wave from the space to earth, again earth to space. That is a troposphere. So that frequency range is about 30 megahertz. About 30 megahertz. That is a phase wave propagation. And next topic is a line of sight propagation. Okay, so line of sight propagation using for all three wave propagation. All three wave propagation means that is a ground wave propagation, phase wave propagation, and the sky wave propagation. Okay, so you can using the ground wave propagation, phase wave propagation, and the sky wave propagation. So what is the process of line of sight? So you can transmit the waves for the particular distance and accurate, you got the accurate output. That is a line of sight propagation. Okay, so you can transmit the electromagnetic waves for the space wave propagation, sky wave propagation, or ground wave propagation. So what is the concept of line of sight? You can identify the unwanted signal that rectifies the line of sight propagation. Okay, so generally this is a transmitter antenna and the receiver antenna. That operation is available at signal propagation. That is a line of sight. Here is a line of sight. You can calculating the transmitter and the receiver in between the line of sight. You can calculating the line of sight means. So you can transmit the electromagnetic waves transmitter side and the receiver side. You can calculating the transmitter antenna and the receiver antenna between the transmitter and the receiver antenna. That is a line of sight. Okay. Okay. So this is a line of sight operation. So what is mean by line of sight propagation means that is a transmitting and the receiving antenna must be within line of sight. Okay, must be within line of sight. So what is the range of line of sight for the satellite communication and ground communication? So satellite communication means that is a phase wave propagation and sky wave propagation. Ground communication means that is a ground wave propagation. Okay, so you can using the line of sight for the satellite communication that signal is above 30 megahertz, not reflected by the ionosphere. Okay, so that signal is above 30 megahertz, not reflected to the ionosphere. So you can using the satellite communication for the line of sight, you can transmit and receive the above the surface. Above the surface means above the earth. That is you can using only a phase wave and a sky wave. That is a satellite communication. Okay, and next one is a ground wave communication. So ground wave communication, antenna within effective line of sight due to refraction. Okay, due to refraction. So ground wave propagation for the line of sight, that signal goes to the sky wave propagation and phase wave propagation. That means ionosphere. That the signal goes to the ionosphere or troposphere. Okay, so effective line of sight due to refraction. So the signal goes to the ionosphere or atmosphere, reflected to the earth, again goes to the ionosphere. So you can calculating that area for the line of sight for the ground wave propagation. I repeat again the concept. So satellite communication means you can using the above 30 megahertz signal, not reflected to the ionosphere, not reflected to the ionosphere. Okay, the ground wave propagation you can reflected the wave for the ionosphere, reflected to the wave for the ionosphere. You can calculating that distance. So you can transmit the ionosphere, return back to the earth. You can calculating this distance for the line of sight. Okay, so you can transmit the ionosphere and the earth. So you can calculating the line of sight. Line of sight is here this distance. So ionosphere to the earth. Again, you can transmit the earth to ionosphere. You can calculate in the line of sight. So what is the purpose of this line of sight? You can identify the and rectify the unwanted signal. Okay, and refraction. What is meant by refraction? Okay, what is meant by refraction? So bending of microwave by the atmosphere. Bending of microwave by the atmosphere. So microwave means you can using the electromagnetic waves or radio waves. Electromagnetic waves or the radio waves. So what is the definition and operation of refraction? Means velocity of electromagnetic wave is a function of the density of the medium. So velocity of electromagnetic waves is a function of the density of the medium. Density of the medium. So what is the refraction means? You can transmit the electromagnetic waves for the particular distance, again reflected to the ionosphere for the particular distance. Again, you can transmit the electromagnetic wave from the earth to ionosphere. That is the velocity of electromagnetic wave is a function of the density of medium. Okay, and next point, when wave changes medium and the speed changes. Okay, you can change the medium. You can identify the medium. What ranges you can transmit the electromagnetic waves. So you can identify the medium, and also you can change the speed. Suppose you can transmit the electromagnetic waves for the particular medium means you can change and identify the medium and the speed. Okay, and the last point, wave bends at a boundary between medium. So wave bends at the boundary between medium. So you can transmit the electromagnetic waves, ionosphere to earth, earth to ionosphere. That is a bend. Okay, bend at the boundary between medium. Okay, so what is the main concept of this line of sight calculation? You can eliminate the unwanted signal. For accurate signal goes to the transmitter side and the receiver side. That is a line of sight calculation. So this line of sight calculation you can use for satellite communication and ground communication. So that's all about line of sight. And the next one is a critical frequency. So what is meant by critical frequency means? That is a definition. This denoted as FC. So this denoted as FC. So critical frequency is denoted as FC. So critical frequency for given layer is defined as the highest frequency of wave that will be returned to the earth by that layer have been beamed normally at it. Okay. So what is a critical frequency means? So you can identify the highest frequency, return back to the earth. That range is called critical frequency. So you can transmit the radio waves from the ionosphere, return back to the earth. Okay, return back to the earth, that range is called the critical frequency. Okay, return back to the earth, that ranges are critical frequency, that denoted as Fc. That formula is Fc is equal to square root of 81 n maximum. Okay, 81 n maximum. That is a formula, critical frequency, that is a formula. Okay, so Fc is equal to square root of 81 n maximum. So here n maximum is a maximum ionization density, that is number of electron per unit volume. Per unit volume. Okay, so what is a n maximum is a maximum ionization density, that is a number of electron per unit that volume. So that is a critical frequency. Okay, critical frequency, that is an important one. Okay, so what is the critical frequency means? That highest frequency return back to the earth, you can calculating that return back to the earth and ionosphere. That range is called the critical frequency. So Fc is equal to, that denoted as Fc is equal to square root of 81 n maximum. Okay, here n maximum is a maximum ionization density. That means number of electron per unit volume. Next one is a maximum usable frequency, MUF. Okay, so maximum usable frequency is simply denoted as MUF. So a maximum usable frequency defined as the highest frequency at which it is reflected by the ionospheric layer at the angle of incident other than the normal incident. Okay, incident other than the normal incident. Okay, so what is the maximum usable frequency? You can transmit the highest frequency for the radio wave or electromagnetic wave. So this is a diagram. So you can transmit the electromagnetic wave for the ionosphere. Okay, electromagnetic for the ionosphere and reflected to the earth for the receiver. So you can calculating this angle, return back to the earth. You can calculating this angle, that is called maximum usable frequency. You can calculating this angle, that is called the maximum usable frequency. That formula is MUF is equal to Fc x secant theta, and secant theta is equal to 1 divided by cos theta. Okay, so what is the concept of maximum usable frequency? That is the highest frequency reflected by the ionospheric layer at the angle of incident other than the normal incident. Okay, incident other than the normal incident. That means you can transmit the electromagnetic wave from the ionosphere, return back to the earth. Okay, you can calculating that this angle is called MUF, maximum usable frequency. Okay, you can calculate here, that is the transmitter side, and the receiver side. You can also calculate here, that is a angle of MUF. Okay, and next one.